Ground fault circuit interrupters, often abbreviated as GFCIs, are crucial safety devices designed to protect individuals from electrical shock. Their operation is based on the principle of detecting imbalances in the electrical current flowing through a circuit. In a standard electrical circuit, the current flowing to an appliance or device should equal the current returning. A GFCI continuously monitors this balance. If a difference of even a few milliamperes is detected, it indicates that some current is leaking, potentially through a person who is touching a live conductor and ground. When this leakage is detected, the GFCI trips rapidly, interrupting the circuit and cutting off the power, thereby preventing a severe or fatal electrical shock. The speed of this interruption is critical, typically occurring within a fraction of a second. This rapid response is what makes GFCIs so effective at preventing injury. GFCIs are designed to protect against the most common type of electrical shock hazard, which is ground faults. A ground fault occurs when an electrical current strays from its intended path and flows to ground through an unintended conductor, such as a person. This can happen due to damaged insulation, faulty wiring, or water coming into contact with electrical components. By detecting these ground faults and quickly cutting off the power, GFCIs significantly reduce the risk of electrical shock. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for safe electrical installation and maintenance. It is published by the National Fire Protection Association, or NFPA, and is updated every 3 years. The NEC is widely adopted throughout the United States and serves as the benchmark for electrical safety in residential, commercial, and industrial settings. The code covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Adherence to the NEC is essential for ensuring the safety of people and property from electrical hazards. The NEC is organized into chapters, articles, and sections, each addressing specific aspects of electrical installations. It provides detailed requirements for materials, equipment, and installation practices. The code also includes tables and examples to aid in understanding and applying the requirements. Local jurisdictions often adopt and enforce the NEC, sometimes with local amendments to address specific needs or conditions. It is important to consult the latest edition of the NEC and any applicable local amendments when planning or performing electrical work. Section 210.8 of the National Electrical Code specifically addresses ground fault circuit interrupter protection for personnel. This section outlines the locations where GFCI protection is required to minimize the risk of electrical shock. The requirements in 210.8 vary depending on the type of occupancy, such as dwelling units, commercial buildings, and industrial facilities. The NEC distinguishes between dwelling units and other than dwelling units. Dwelling units typically refer to residential occupancies such as houses, apartments, and condominiums. Other than dwelling units encompass a wide range of non-residential occupancies, including commercial buildings, offices, stores, schools, and industrial facilities. The requirements for GFCI protection may differ between these two types of occupancies due to the different electrical hazards and usage patterns associated with each. In dwelling units, GFCI protection is generally required in areas where there is a higher risk of exposure to water or moisture, such as bathrooms, kitchens, and outdoor locations. The NEC specifies the specific locations within dwelling units where GFCI protection is mandatory. In other than dwelling units, the requirements for GFCI protection are also based on the potential for exposure to water or moisture. However, the specific locations where GFCI protection is required may differ from those in dwelling units. For example, GFCI protection may be required in commercial kitchens, laundry areas, and certain types of industrial facilities. The specific requirements for GFCI protection in other than dwelling units are detailed in 210.8 of the NEC. Bathrooms in other than dwellings were required to have GFCI protection starting with the 1996 National Electrical Code. Prior to the 1996 NEC, GFCI protection was not mandated for bathrooms in commercial or industrial buildings. This change in the code reflected a growing awareness of the electrical hazards associated with bathrooms, particularly the risk of electrical shock due to the presence of water and electrical appliances. The addition of this requirement significantly enhanced electrical safety in non-residential bathrooms. The 1996 NEC marked a significant step forward in electrical safety by extending GFCI protection to bathrooms in non-dwelling occupancies. This change addressed a previously existing gap in the code and provided increased protection for individuals using these facilities. The requirement for GFCI protection in bathrooms in other than dwellings is found in 210.8 of the NEC. This section specifically addresses GFCI protection for personnel in dwelling units and other than dwelling units. It outlines the specific locations where GFCI protection is required, including bathrooms. The wording of 210.8 clearly states that GFCI protection is mandatory for receptacles installed in bathrooms of commercial, industrial, and other non-residential buildings. The purpose of requiring GFCI protection in bathrooms is to protect individuals from electrical shock hazards. Bathrooms typically contain water sources, such as sinks, showers, and bathtubs, which can increase the risk of electrical shock if electrical appliances or devices come into contact with water. By requiring GFCI protection, the NEC aims to minimize the risk of electrical shock in these environments. GFCI protection works by monitoring the current flowing through a circuit. If a ground fault is detected, the GFCI quickly interrupts the circuit, cutting off the power and preventing electrical shock. This rapid response is essential for protecting individuals from serious injury or death. Ground faults occur when electrical current strays from its intended path and flows to ground through an unintended conductor, such as a person. This can happen due to damaged insulation, faulty wiring, or water coming into contact with electrical components. GFCI protection is designed to detect these ground faults and quickly cut off the power, thereby preventing electrical shock. The addition of the GFCI requirement for bathrooms in other than dwellings in the 1996 NEC was a significant improvement in electrical safety. It ensured that individuals using these facilities were protected from the risk of electrical shock. This change reflected a growing awareness of the importance of GFCI protection in areas where there is a higher risk of exposure to water and electricity. Prior to 1996, the NEC focused primarily on GFCI protection in residential occupancies. The extension of this requirement to non-residential occupancies demonstrated a commitment to improving electrical safety across all types of buildings. The NEC is continuously updated to reflect advancements in technology and changes in safety standards. The addition of the GFCI requirement for bathrooms and other than dwellings in 1996 was one example of how the NEC evolves to address emerging electrical hazards and improve overall safety. It is important for electricians, electrical contractors, and building owners to stay informed about the latest changes in the NEC to ensure that their electrical installations are safe and compliant. The NEC is a complex and comprehensive document, and it is essential to consult the latest edition when planning or performing electrical work. Local jurisdictions may also have their own amendments to the NEC, so it is important to check with local authorities to ensure compliance with all applicable regulations. The requirement for GFCI protection in bathrooms in other than dwellings has been maintained in subsequent editions of the NEC. This demonstrates the ongoing importance of this safety measure in protecting individuals from electrical shock hazards. The specific requirements for GFCI protection may be updated or clarified in each new edition of the NEC, so it is important to stay informed about the latest changes. The NEC also provides guidance on the proper installation and testing of GFCIs. It specifies the types of receptacles that are required to be GFCI protected, as well as the methods for testing GFCIs to ensure that they are functioning properly. Regular testing of GFCIs is essential for ensuring that they will provide adequate protection in the event of a ground fault. The NEC recommends testing GFCIs at least once a month using the test button on the receptacle. If the GFCI does not trip when the test button is pressed, it should be replaced immediately. In addition to the requirements for GFCI protection in bathrooms, the NEC also includes requirements for GFCI protection in other areas where there is a higher risk of exposure to water or moisture, such as kitchens, laundry areas, and outdoor locations. These requirements apply to both dwelling units and other than dwelling units. The NEC is a valuable resource for electricians, electrical contractors, and building owners. It provides detailed guidance on how to design, install, and maintain safe electrical systems. By following the requirements of the NEC, it is possible to minimize the risk of electrical hazards and protect people and property from harm. The addition of the GFCI requirement for bathrooms in other than dwellings in the 1996 NEC was a significant step forward in electrical safety. It demonstrated a commitment to protecting individuals from electrical shock hazards in all types of buildings. This requirement remains in effect today and continues to play a vital role in preventing electrical injuries and fatalities. Ground fault circuit interrupters are readily available at most hardware and electrical supply stores. They are relatively inexpensive and easy to install, making them a cost-effective way to improve electrical safety. When installing GFCIs, it is important to follow the manufacturer's instructions carefully. Improper installation can compromise the effectiveness of the GFCI and may even create additional hazards. It is also important to ensure that the GFCI is properly grounded. A properly grounded GFCI provides the best protection against electrical shock. In addition to installing GFCIs, it is also important to practice other electrical safety measures such as avoiding the use of electrical appliances near water, keeping electrical cords in good condition, and never overloading electrical circuits. By following these simple precautions, it is possible to significantly reduce the risk of electrical hazards in the home and workplace. The NEC is a constantly evolving document, and it is important to stay informed about the latest changes and updates. By doing so, it is possible to ensure that electrical systems are safe and compliant with the latest standards. The NEC is a valuable resource for anyone involved in the design, installation, or maintenance of electrical systems. The information provided in the NEC can help to prevent electrical hazards and protect people and property from harm. Remember that the requirements for kitchens were added in the 2002 NEC.